Okay, so we have an Olympic diver with a mass of 54 kilograms standing at the end of a uniform 3.8 meter diving board with a mass of 25 kilograms. So we have here is our diver right here with their mass, their force due to gravity, and a uniform board, meaning the center of mass is in the very center of it, and we have gravity acting on that about this fulcrum right here. And we're told some distances here. We're told that the fulcrum supporting the diving board is 1.3 meters, so that's this value right here, 1.3 meters from the end of the bolted end. And we're asked what is the force that must be applied by the bolt in order to keep the whole thing balanced, okay? Keep it from rotating. So we know that it's 3.8 meters long, so we can figure out some lengths here. So the distances from the fulcrum are the ones that matter. So 1.3 to the bolt. Okay, so 3.8 divided by 2, that's the center of mass, minus the 1.3 gives us this little distance right here. That's the R value for our center of mass, and the R value for the diver is going to be 3.8 minus 1.3 meters, gives us 2.5. So we need to apply our sum of our torques equals 0 equation. And from that, if we go look at our counterclockwise torques first, we're going to have F times what I've called R, which is 1.3 meters, minus the clockwise torques. So the one from the diver is just FG1 times R1 minus FG2 times R2. And this all equals 0. So I can solve for F. It's just going to be FG1 times R1 plus FG2 times R2, all divided by R. And I know all of those values, so I can just plug them all straight in. So FG1 is just M1G, which is 54 kilograms times 9.81 meters per second squared, times R1, which is 2.5 meters, plus 25 kilograms times G, times R2, which is 0.6 meters, divided by the R, which is 1.3 meters. And then when I plug all of that in, I find out the force that I need to hold everything in place is going to be 1130 newtons.